Hello friends, this video Limits and Derivatives Part 5 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched Part 1 to Part 4. Let's take one more example. Here also we have to find the left limit, right limit and the limit for this function at x is equal to 0. So let's suppose this is 0, this is 1, this is 2. So this function says that the function is equal to 1 for x equal to 0. For x equal to 0, this function value is 1. Because this is 1, this is 2, this is 3. And any other value of this x, you take 1, you can take minus 1, you can 2, any value, this value is 2. So this fx 0 is not included because at 0, this value is already 1. And for any other value, this is equal to 2. So we'll get a graph like this, where at x is equal to 0, the value of function is 1, y is equal to 1, and x is equal to any value other than 0, the y is equal to 2. Here also now let's find the left hand limit and right hand limit. So the left hand limit will be x is 0 minus for fx, and that we can take any value of x that is less than 0. You can take minus 0.0001, correct? So f of this function at this point minus 0.001 is equal to 2. You can see, so this value is. Similarly, let's find the right hand limit, that is limit of x 0 plus. We are approaching this from the right side, so we can of fx, we can assume this value as f of, let's suppose, plus 0.0001, because this point is plus 0.001. Let's suppose we can take plus 0.002 also, we can take any value that is near to 0 and greater than 0. For this value also you see the y is equal to 2. So here we see that left limit is equal to right limit, correct? We can see that because the left limit here is 2 and right limit here is 2. So we can say that limit x is tending to 0 for fx, this exists, right? So if this exists, the value of this is nothing but 2. Why? Because that is equal to left limit or right limit. Since both are equal, so we can take any value. Here we have to find the left limit, right limit and limit at x equal to pi by 2 for sin x. So this is 0, and let me assume this is pi by 2, and then this is. So if you know that sine of x, sine 0 is 0, sine pi by 2 is 1. So let me suppose this is 1 actually. This guy is 1. And then again sine pi is 0. So this function is something like this. You know the sine function? Sine function is something like this. It will again go to this, like this. Correct? Now we have to find the limit at x is equal to pi by 2. So let's approach this from the left hand side. So what we get is limit x tends to pi by 2 minus of f of x is equal to nothing but f of pi by 2 minus 0.001, let's suppose. So that value is nothing but sine of pi by 2 minus 0.00. So if you see pi by 2 minus 0.01, this value is almost equal to 1. Correct? This can be, I think, 0.9999. It's almost equal to 1. This value if you see. Similarly, let's find the right limit. Right limit is x tends to pi by 2 plus of fx. This is nothing but f of pi by 2 plus 0.001, or you can say plus 0.0001 also. We just need some value that is near to pi by 2 and that is greater than pi by 2. This is nothing but sine of pi by 2 plus 0.0001. This is pi by 2 plus 0.001, this point here, and for this point you see it's little less than 1, and we can say that is also equal to 0.999, almost. And that value is almost equal to 1. So here also if you see that the left limit is equal to right limit, correct? Since the left limit equal to right limit, we can say that limit x tends to pi by 2 of fx exists. And since this limit exists, its value is nothing but 1. We can take any of these values. What we have done, we have found the left limit, we have found the right limit, and we found that both are almost equal to 1. And we told that left limit is equal to right limit, so the limit exists and the value is 1. We'll take one more example. Here also we have to find the left limit, right limit, and the limit at x is equal to 0 for this function fx. X is equal to minus 4, where x is less than 4, x is equal to 0 for x is equal to 0, and x is equal to x plus 3, y is equal to x plus 3 for x is greater than 0. So let's draw first for x equal to 0, so we get this point 0, 0. Let's draw for x is greater than 0. So for 1, this will be 1 plus 3 is equal to 4. So let's suppose this value is 2, this is 4, this is 6, this is 8. So for 1, this value is 4, for this is 1, this is 2, this is 3, this is minus 1. For 2, the value is 2 plus 3, that is 5, be somewhere else. For 3, the value is 3 plus 3, 6. 3, the value is 3 plus, plus. For 1, the value is 1 plus 3, 4. This is somewhere here. It's not the point. For 3, the value is 3 plus 3, that is 6. So we get a graph like this. We'll get a graph like this. But for 0, this is not valid. So we'll put a hollow circle here. This is the graph for any number greater than 0. For x equal to 1, you get 1 plus 3. That is 4. For x equal to 2, you get 2 plus 3. That is 5. 2 plus 3 is 5. X equal to 3, you get 3 plus 3. That is 6. Now let's draw for negative 1. X equal to minus 1. This value is minus 1, minus 4. That is minus 5. X equal to minus 2. This is minus 2, minus 4. This is minus 6. X equal to minus 3. You get minus 3, minus 4. That is minus 7. This is the value we get for various values of x. So x equal to minus 1, you get minus 5. So this is minus 2, minus 4, minus 5, minus 6, sorry. This is minus 8. So x equal to minus 1, you get minus 5. So minus 5 is somewhere here. X equal to minus 2, you get minus 6. This is minus 6. And then you get minus 7 here. This is minus 7. And then you get minus 8, I think. So if you see this graph, this is somewhere here. This graph will be something like this. And x is equal to, for 0, this won't touch actually. This will be something like this. So what we have done this, x is equal to 0, this value is 0. X is equal to 0.001, also this equation is used. X is equal to minus 0.001, this equation is used because this value is less than 0. And x is equal to 0, this point is used. So now let's find the value. Limit of x is 0 minus of this function. This is nothing but f of minus 0.0001. Any number that is less than 0 and almost equal to 0. So for this point, we have to use this equation, correct? So for this point, this equation is minus 0.0001 minus 4. This is the value you get, and this is nothing but minus 4.0001, and that is almost equal to 4, minus 4. Similarly, when I am to find limit of x of 0 plus of fx, this is nothing but f of plus 0.0001, and that is nothing but, in this case, if you are talking about any number greater than 0, here we use this equation. So this is nothing but 0.0001 plus 3, right? Because x plus 3 is the equation. And this value is 3.0001, which is almost equal to 3. So when here we see this value is minus 4 and this value is 3. So here we can say that left limit is not equal to, is not equal to right limit. Correct? Left limit is not equal to right limit. Since left limit is not equal to right limit, I can say that limit of x tends to 0 for fx does not exist. Here is not exist or not defined. Correct? What we have done, we have just plotted the graph, we have found left limit and right limit, and we found that left limit and right limit are not equal, so we can say that for this function at x equal to 0, the limit doesn't exist. But if you want to find the value for x equal to 2 or x equal to 3 or minus 1 minus 2, for those points, this limit will exist, but for x equal to 0, it does not exist. Also, we can see from the graph also, at x is equal to 0, there is a broken thing, it is not continuous. So we can observe that for any point in the graph, if it is continuous, for example at x equal to 3, it is continuous. So for this point the limit will exist. For x equal to 2, it is continuous. So at this point also limit will exist. But for any point where it is not continuous or not defined, at those points the limit doesn't exist. For example, in this case also, at x equal to 2, since the graph is not continuous, the limit doesn't exist. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.